Objective: to learn the human eye's mechanism of accommodation. The eye is the organ of vision, and it makes accommodations allowing you to see objects clearly at varying distances. Before we look at those accommodations, we first need a basic understanding of how the eye works. Light waves from an object will enter the eye through the cornea, a transparent dome covering the front of the eye. The light will then pass through the iris, a colored ring-shaped membrane located behind the cornea. The opening of the iris is the pupil. Changes in the intensity of incoming light will trigger changes in the size of the pupil. In brighter light, the pupil will constrict, and in dimmer light, it will dilate. A crystalline lens located behind the iris will focus the light rays so they converge on a nodal point, where the image of the object will be reversed and inverted. The light will continue through the vitreous humor, a clear gel filling the eye, before focusing on the retina. In the retina, light impulses will be converted to electrical signals. These signals will be transmitted through the optic nerve to the visual center of the brain in the occipital lobe. The brain will translate these electrical signals into an upright image. But what happens when distances between the eye and the object vary? Your eye can actually adjust its lens according to an object's distance. When the object is far away, the ciliary muscles will relax, causing the lens to become thinner. This thinning of the lens will increase the focal length, and the focus will be on the retina. This allows a clear image of the object to form on the retina. When the object is nearer the eye, the rays from the object will fall beyond the retina, creating a blurred image. In this case, the ciliary muscles will contract and the lens will accommodate by becoming thicker. The thickening of the lens will shorten the focal length, allowing the rays to converge on the retina, forming a clear image of the object. Any non-accommodation of the lens will lead to vision abnormalities such as myopia or hyperopia. In people with myopia or nearsightedness, the eye will focus the image of a distant object in front of the retina instead of on the retina. As a result, a blurred image will be formed. Myopia can be corrected through the use of a concave lens. In hyperopia or farsightedness, the eye will focus the image of nearby objects behind the retina. This condition can be corrected through the use of a convex lens. Summary: the eye is the organ of sight. It can focus on regions of varying brightness and distance. The eye can accommodate the incoming rays by adjusting the focus. A thinner lens will have a longer focal length. A thicker lens will have a shorter focal length.